Here we start with new chapter which is called Relations and Functions. In JEE syllabus, the chapter function plays very important role, and we require all these functions in calculus thoroughly, in limits, differentiation, in integration, etc. So we must know what is a function. Before that, we start with relation. To start with relation, let me consider two non-empty sets. Suppose A is equal to some A comma B. B is equal to the set containing 1, 2, 3. These are the two non-empty sets. I want to define relation between the two. Now, let us define one set. That set is denoted by A cross B, called Cartesian product of A and B, and is defined to be set of order pairs x comma y, such that this first element x comes from the first set. So x belongs to A, and the second element y comes from the second set. So y belongs to B. This set of order pairs is called Cartesian product. Of the two sets A and B. Now in this example, if I want to form a set A cross B, what I can form? I can relate this A with 1 or 2 or 3. So I have pairs A1, A2, A3. Likewise, B can be related with what? 1, 2 and 3 to get B comma 1, B comma 2, B comma 3. Any other possibility is there to form an order pair AB? No, because first element should come from the first set and the second element should come from what? The second set. So with A, all possibilities 1, 2, 3 are considered, and with B, all possibilities 1, 2, 3 are considered. So A cross B contains how many order pairs? 1, 2, 3, 4, 5 and 6. So number of elements in A cross B is equal to 6, and which I can write as 2 into 3, which is number of elements in A into number of elements in B. So number of elements in Cartesian product A cross B is same as number of elements in A multiplied by number of elements in B. Now can we say B cross A is same as A cross B? Answer is no, because this pair is an order pair. So if I want to form B cross A, I should take in first place elements of B only. So with 1 I can have A and B. Similarly with 2 I will have A, B and 3A, 3C, B. So this way B cross A is formed. So because A comma 1 is not equal to 1 comma A unless A equal to 1, these two elements are different. Hence these two sets are also different. Hence we can say that in general Cartesian product A cross B is not equal to B cross A, means Cartesian product is not commutative. I cannot write A cross B is equal to B cross A. I cannot write. So A cross B is not equal to what? B cross A. Of course, the number of elements in B cross A is same as the number of elements in what? A cross B. But the two sets are unequal. Two sets are different from each other. A pair XY is called an order pair. If I equate XA with AB, then X has to be equal to A and Y has to be equal to B. Then we say that the pair is what? Order pair. So there is importance to the order in which the elements are placed. Now, there is one result from the set theory that if a certain element A contains n elements, then A possesses 2 raised to n subsets. What I am saying is, any set A is containing n elements, say x1, x2, dot, 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 xn, all are distinct. Then A has how many subsets? Answer is 2 raised to n. For example, suppose if I consider A is equal to 1 or A comma B comma C. How many subsets of A I can form? Very clearly, empty set is the subset of every set. So this set contains no element. Set containing single elements. This is a subset of this because member of this is a member of this. Similarly, B, C, all these are subsets of A containing single elements. Likewise, I can form subsets of A which will contain 2 elements. So, namely here A comma B, B comma C, C comma A. And subset of A which contains 3 elements. So, the subset must be the set itself. So, it is the set A, B, C means A. You know that phi and the set A are called improper subsets of capital A, while the other are the proper subsets. A set is called a proper subset of another set. If all elements of the first set, suppose A is one set, B is another set. A is said to be a proper subset of B if every member of A is a member of B, but there exists at least one element in B which is not in A. For example, if I choose A equal to ABC, same as this. So, in order to say A is a subset of B, all these members should be present in B. So, ABC should be there. And if this is to be a proper subset, B should contains at least one element which is not in what? A. So, suppose that is D. So, in this case, I can say that set A is a proper subset of B. Otherwise, if I remove D, they are equal. So, what I am saying was, if a set contains 3 elements, it has how many subsets? All these are total number of subsets of A. So, 1, 2, 3, 4, 5, 6, 7 and 8. So, there are 8 subsets of what? Capital A. So, 8 subsets means 8 number I can write 2 to the power 3. This 3 is nothing but the number of elements in A. So, I can write 2 raised to what? N of A. So, if A has n elements, then A possesses 2 raised to n means 2 raised to number of elements in the set A, those many subsets. So, A possesses 2 raised to n subsets. If this idea is clear, we will proceed to understand what is a relation now. Here, 2 sets A and B are considered, and collecting one element from this and another element to form an order pair, I'm getting element of A cross B. This way, the relation between A and B is established. Moment I choose an element from A and B, and if I write that as an order pair, then I am getting a relation between A and B. Relation between A and B exists moment an element of capital A is related with element of capital B. Therefore, if I choose any non-empty subset of A cross B, that will establish the relation between A and B. For example, 1, 2, 3, 4, 5, 6. 6 elements are there. If I choose any number of elements from A cross B to form one set, say capital R. So suppose R is what? A comma 1, B comma 3. So this element and this element I have chosen. But this gives you the relation between two sets A and B given by this relation. So this is a relation between A and B executed like this. But this relation is nothing but a set which is a subset of A cross B. So we can say that any subset of A cross B which is non-empty is a relation between the two sets A and B, because moment I choose elements, A and B are getting connected, so relation is getting established. Therefore, we can define relation between the two sets A and B as any non-empty subset of what? A cross B. So relation between A and B is a non-empty subset of A cross B. This you remember. Now, if by choosing either 1, 2, 3 or all the elements from the set A cross B, I can form number of subsets, and each subset is nothing but a relation. Therefore, question is how many such relations possible from the set A to the set B. When I say from the set A to the set B, I should write A first and B second. So, how many such relations are possible? So, number of relations is nothing but number of non-empty subsets of what? A cross B. Just now we have seen a result that if A contains n elements, then A has 2 raised to n subsets. So as many subsets, as many non-empty subsets of A, those many relations will get. So A cross B contains 6 elements. So number of elements of A cross B is equal to 6. Therefore, A cross B possesses 2 raised to 6, 64 subsets, out of which 1 is empty, else are non-empty. Means 63 subsets exist. Means 63 relations exist between the set A and the set B. So this way one can have a relation between A and B by choosing any subset of what? A cross B. Now, having gone through this, we will execute relations as follows. Suppose this is the Venn diagram in which I am executing the relation between the two sets. Suppose capital A is this and capital B is this. So suppose A, B, C, D. These are the 4 members of capital A. 1, 2, 3, 4, 5, 6. Suppose these are the 6 members of capital A. I am relating suppose A with 1, B with 2, C with 3 and D with 4. Then I get some relation R from A to B, which is a set containing the elements A, 1, B, 2, C, 3, D, 4. Here elements 5 and 6 of B are not related. But this is a relation because one arrow is going from this set to that set, so relation established. Let me consider another example. Suppose in the same example, I have A, B, some relation is there, A, B, C, D, 1, 2, 3, 4, 5 and 6. I am saying that A is related with 2, C is also related with 2, B with 3 say, and D is not related. Still, when these two are executed by arrows, relation exists between A and B. So in this, every member of relation, every member of A is related. Here, every member of A is not related, but it is a relation. Take another example. This is A, this is B, same A, B, C D. Let me choose 1, 2, 3, 4, 5, 6. This time, A is related with 3, B is related with 3, C is also related with 3, and D is also related with what? 3. So, here, relation S from the set A to the set B exists, and all elements of capital A are related with what? The same number 3. So, this is again a relation. Let me consider one more example. Here, suppose A is related with 1 and A is related with 5. B is related with 2, C with 3 and D with suppose 6. So because arrows are connecting the elements, there exists a relation between the set A and set B, denoted by what? U. So here I have given you some examples, and I want to explain the concept of what? Function, with the help of what? Relation. These are the functions, these are the relations, and I want to say a relation as a function if the following conditions are satisfied. A relation from the set A to the set B. I have few relations over here. How many of these are functions that I want to define? So my definition of function is as follows. A relation R from the set A to the set B is called a function. A relation R from the set A to the set B, denoted like this, is called a function if every member of capital A is related. Look into this example. Here A, B, C, D. From every member, arrow has gone. So every member is related here. So first condition is what? Every member of capital A is related. And every member of capital A is uniquely related. Now what do you mean by every member is uniquely related? Every member is to be related. So here A is related, B is related, C is related. But once A is related with some number 1, A is again not re-related. No arrow is passing from A towards any other element other than 1 of B. Similarly, this happens for B, C and D. Therefore, such a relation can be called what? A function. So, relation R from A to B is function if this relation relates every element of A, and every element of A is uniquely related, means no element of A is related with more than one element of what? B. For example, here you see that A is related with 1 and A is related with 5 also. Therefore, even all the elements of capital A are related. A is related with more than one element, hence this relation cannot be called a function. So try to understand the difference between the relation and the function. Relation is called a function, or a function is that relation which relates every member of A, and every member of A is uniquely related. Here A is related with 2, B with 3, C with 2, but D is not related with any element. So, as every member is not related here, D is not related with anything. So, this relation cannot be called a function. So, for a function, this kind of situation should be there, that every member is related, and once every member is related, there is no chance to again relate it with any other element of what? Capital B. Such relation is called what? A function. I think this notion of function is now clear to you. Now, what kind of possible relations possible from the set A to the set B? We can also name the relation as a correspondence. Here A is with 1, B is with 2, C with 3, D with 4. So distinct element has distinct images. When this is the case, we say that the relation is 1-1. So relation is 1-1 means there is a 1-1 correspondence between the elements of capital A and capital B. Here we see that A, B, C, D. So two elements, more than one element of capital A is related with what? The same element 3 of B. So such kind of relation is called what? Many one relation. So many are going to one place, just like that. So it is what? A many one relation. So second relation is what? Many one relation. Then one many relation. One element is related with many elements. So here A is related with what? 1, and A is related with what? 5. Then it may happen that I have certain relation over here, say V, A, B, C, D, 1, 2, 3, 4, 5, 6. 1 is related with A is related with 1, A is related with 2, B is also related with 1, C is also related with 2, D is with 5. So here one element is related with many elements, and here many elements, say A and B, both are related with what? 1. So such kind of relation is called what? Many relations. Now, among these 4 types, these are the only 4 possibilities: 1-1, many one, one many, many. Among these, which kind of relation, which kind of correspondence is a function that we will see very quickly. 1-1 relation, this is clearly function. It was said function, I discussed that. So 1-1 relation is a function. If I consider many one relation is over here, say A, B, C, D. Many are going to one place, or minimum 2 elements are going to one place. Then such a relation is again a function. But one many, no. It is against the definition of function. Every element of the set A should be related, but it should be uniquely related. So once A is related with 1, it is not allowed for A to relate with any other element. So as it is related with 5, I can't say that this relation is a function. So one many relation is not a function. And of course, if one many is not a function, many would not be a function. So there are only two kinds of correspondences which are functions, namely one function and many one. One relation is a function and many one relation is a function. So these are the only two kinds of relations which could be functions.